begin.
We should like point it as on control.
Welcome to Alright. This is section 7-1. And the date is March 8th, 2013. So we're starting a new chapter. 2016. Starting a new chapter on equations and functions. There's going to be obviously equations. We're going to have graphing. And a little bit more of an algebra chapter. Okay?
I'm ecstatic.
All right. So here is the first slide. We've got a couple of key vocab words in here. It says a relation expresses how one group, which we call the input, is related to another group, which we call the output. That relation, and that input and the output, that is a set of ordered pairs. And even I'm going to highlight ordered pairs as a key vocab word. So a relation expresses how one group is related to another group. One group is the input, the other group is the output. And Haley, you hit record, yes?
Mm-hmm.
Okay, we're just checking. Serena?
Is there gonna be like positives and negatives in this chapter?
There are going to be positives and negatives. Because if we think about the coordinate grid, does the coordinate grid just have positive numbers?
No.
No, quadrant 1 is positive, but quadrant 2 is negative positive. Quadrant 3 is negative negative. Quadrant 4, positive negative. So we will have positives and negatives in this chapter. We did.
Did we already do this?
Did we do this? No.
We did graph.
You did graphing. Yep, we talked about the coordinate grid. And I think that was way back, chapter 2 maybe? I think so. I know in IE one day you practiced graphing on the coordinate grid.
Oh yeah, I remember
Yep,
that.
Battleship, or I have Who Has. So, if we look on this chart, oops. And I'm going to try to zoom in so we can see this a little bit better. How does that look on there, Haley? A little bit more clear?
It's pretty good.
Pretty good? Okay. So here's an example of a relation.
Should we write that?
You could. You could. It says binder, gel pens, notebook.
Gel pen.
So the input is the binder. The output is how much it costs. So it's $3. The gel pens, the input are the gel pens. The output is the $1.50. Input is the notebook. The output is the price of the notebook, which is 75 cents.
$3 for a binder. That's pretty. So is it watching the video?
Yeah. So they're at home gonna watch the video.
How's it gonna watch it at home?
That's what I'm saying.
Yeah, the campus.
It's gonna be on my big campus.
What if they don't do that?
What if they don't have a
Then
computer?
they're not doing their homework.
Oh, that's like I'm missing.
Are we gonna have to do that, or we just do the notes?
Yeah, what if you? I would like it if you watch it on my video. If you don't have a computer,
No, I want to just take the notes.
Yeah, I like it better like main.
Okay. So then we also have. Oops. Let me do this. Okay, so the next thing down here, it says if each input has only one output, then the relation is a function. So if each input has only one output, then the relation is a function. So when we look at the input outputs that you guys put down for the binders, gel pens, and notebooks, was there an output for every input?
Yeah.
And just one output for each input?
No. Yeah.
On this one. But if we look over here, and I know that it's a little hard to see, but is there exactly one output for every input?
No.
No, because binder has two outputs. A binder is either $3 or $1.50. So would this be a function?
Yeah.
No. This one wouldn't be a function because it has more than one output for the input of binder. Okay? Zoom up.
Wait,
Go away.
Uh-oh.
Go away.
Oh.
There we go. All right.
Well, I wasn't ready. I was done.
You weren't?
No.
Sorry.
Okay, I'll go.
If each input has only one output, then the relation is a function.
Okay, I'm done.
Serena?
Wait, why isn't it a function? Because they share one.
Yep, so each input can only have one output. So because there's one input of a binder, but it has two outputs. So binder is going to $3 and binder is going to $1.50. So that's two outputs for the one input. Whereas here, each of them has just one output, so it's a function on this one.
Got it.
Okay? All right. Oh, uh-oh. Go back. So the first example says, suppose you can buy magazines for $4 each.
This is easy. You just count by 4.
Okay. So suppose you can buy magazines for $4 each. So if you bought one magazine, how much are you going to pay? $4. If you bought two magazines, how much are you going to pay? $8. And how did you get that $8? Whoa,
8 times
I'm
2.
still in fancy
I
pen.
mean 4 times 2.
4 times 2, which is 8. If you buy 3 magazines, how much are you going to pay? $12. Because it's 4 times 3. And if you buy 4 magazines,
16.
16, because it is 4 times 4. This right here is called a function table. I'm going to make that a little darker and bigger for you. A function table. It is a way to organize your inputs, the rules, and the outputs. So this right here is an example of a function table. What is the input? Brandon?
4.
The input is 4?
No. 1. I don't know. Wait, no,
Which part is the input? Would the number be the input, the multiplied by 4, or the cost?
Number?
The number is the input. What's the output? Shannon? The cost is the output. And then what do you think this is right here? Stone?
Rules?
The rule. It's how you go from the input to the output. So a function rule is the operation or the operations performed on the input to get the output. So you have your input, whatever number you're starting with. You perform the function rule to the input to get the output. All of that is organized on your function table. So if I jump back to the last screen, and I think about the last notes we took and we said it's a function, each input has only one output. Is this a function?
Yeah.
Does each input have only one output?
Yeah.
Does 1 go with any other number besides 4?
No.
Nope. And does 2?
No.
If you put 2 in here, if you multiply 2 by 4, will you get any other number besides 8?
No.
No. So that's a function.
Unless you multiply it wrong.
Yeah.
That'd be funny.
Are you ready for the next one?
Mm-hmm.
Okay, so this is just a picture. You don't have to write this down. It's just a visual picture for you. You start with your input. You plug your input and you do whatever the function rule is. Once you perform that rule, then you have the output. So the input goes into the rule. Whatever you get then for your answer becomes the output. The set of input values we call the domain. You know, there's a lot of vocabulary in this first section, but this vocabulary are words that we're going to use throughout the whole rest of the chapter.
Is this a one chapter?
I don't know. Maybe. Maybe not. The set of input values we call the domain. The set of output values we call the range. So the input values are the domain. The output values are the range.
Ow.
Range can also mean, like when you're talking about statistics, if you have the highest value minus the lowest value. So input goes with domain, output goes with range. All right. When we write our functions, and you don't have to write this down, this is just kind of an FYI, functions are often written as equations with two variables. So it says that Javier saves $20 each month. This right here is a function table that shows his savings after 1, 2, 3, and 4 months. So the input are the number of months. 1 month, he saves $20. He has $20 in his total savings. At 2 months, 2 times 20, he has $40 in his savings. 3 months, 3 times 20 is 60. 4 months, 4 times 20 is 80. This right here, the 1, 2, 3, and 4, is the domain, because that's the input amount. So the 1, 2, 3, and 4 is the domain. The output amount, the output values are also known as the what?
Range.
The range. So domain is 1, 2, 3, and 4. The range is 20, 40, 60, and 80. Multiply by 20, that's our function rule. So remember, whatever we have for input, we plug it into the function rule, and then we have our output. When your homework asks you to list the domain and range, oh, I didn't do that quite nice. There we go. Notice that you're going to list the domain, 1, 2, 3, and 4 separated by a comma, and then they use the brackets to list it. So if I would just rewrite that again, oops. If I would rewrite that again, you'd have the bracket, looks like a parentheses with little extra squigglies. The domain is 1, 2, 3, and 4. Oh, magic pen. And then the same thing with the range. You put the brackets, 20, 40, 60, and 80. Okay?
You did a bracket.
Oh, there we go. If I go back one other spot here, the other thing I want to add to this, the domain are your x values, or your x coordinate. When we talk about graphing, and your range values are then your y coordinate. So if you want to add that into your previous notes. All right, and then if I go back to that problem with Javier, this then is an example of the function table put into an equation form. So 20 times the x is going to equal your y. So in other words, if he works, what was it? 1 month and makes $20 each month, his output, or his y value, is going to be 20. If he works 2 months, which is another input value, 20 times 2, his output was 40. So we can take those function tables and then put it into an equation. So Morgan said you can graph, you can put it in a graph, you can put it into a table, you can put it into an equation. Yes. Those are all the different ways that we can express this. Okay, so we're going to do an example together. It says a student movie ticket, there shouldn't be an S, costs $3. Make a function table that shows the total cost for 1, 2, 3, and 4 tickets. Then identify domain and range. So if we start with our input, what is our input? Okay, so our input is 1, 2, 3, and 4, and what is that? So our input is 1, 2, 3, and 4, but what does that represent?
X coordinate.
Your x coordinate, also the domain, also the, I'm going to write that on there.
Function.
Stone, what did you say?
I said tickets.
Yeah, isn't that how many tickets they're buying?
Oh, yeah.
Yep. So the input then is also the number, come here, pen, number of tickets. And what do you think our function rule is going to be? If I back up, it says that a student movie ticket costs $3. Tyler? The range is our output. Maybe, let's do our output first. Maybe that'll help us make a rule. Tyler, what would our output be if we bought one ticket? It would be $3, right? What would our output be, or what would it cost then if we bought 2 tickets? Shannon? 6? If we bought 3 tickets?
6.
Yeah.
2 times 3? Right? Each ticket costs $3.
Oh.
Austin?
9.
9. And then if we bought 4 tickets, Mackenzie? 12. And what is our output values? I know Tyler said that's our range.
Times 3.
And then the total cost. Yep.
Your y coordinate.
And our y coordinate. Good. So our input is the number of tickets. Our output is the total cost, is how much we're going to pay. So what's our function rule? How do we go from the input to the output? Serena?
The number of tickets times the cost.
The number of tickets times...
Ticket?
Well, what are we multiplying the number of tickets by to get the cost?
Charge?
The charge, which is
$3.
$3. So to go from our input to our output, we are multiplying every input by 3. So this would be 3x. Because whatever we put in for x gives us our y. Because our input is our domain, is our x. Our output is our y. Austin? You what? So what would this one be?
12.
Oh, well, we already did if the input is 2, the output is 6. But if we put in, like, let's say we did it by...
Wait, because I thought when you did the fraction rule, you just times 3 times 4.
Yep, 3 times 4 would be 12, right?
Never mind.
What if we bought 5 tickets, Austin? What would our output be?
16? No, 15.
15. We would pay $15. And this rule then stays the same. 3x, 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 3x.
Oh,
What would our equation look like? If we would wanted to write an equation from this table, what would our equation be? Brandon?
3x equals 1.
3x equals y. What do you think is the benefit if we would write it as an equation as opposed to writing it in this table form? Could be faster. Morgan?
But instead of writing 3x, would you write like 1 times 3? Or do you have to write 3x?
Yeah, you could do 1 times 3, 2 times 3, 3 times 3. Mm-hmm. Yep, it'd still be right. So what's the benefit of writing this as an equation as opposed to writing this on a function table? Devin?
It's less work.
Could be less work. Serena?
Save space.
You could save space. Haley?
Might be easier for some people.
Might be easier for some. And what if I wanted to find out how much it would cost for 100?
And that would be faster.
Would it be faster, or would it be faster to list all the way down to 100?
Be faster.
It would be faster, because I could just plug in 100 for x, and then what would my output be, or what would my...
300.
300, it would be $300. The other thing I wanted us to do is I wanted us to list the domain and the range.
Oh, I did that already.
So what's the domain? According to what we have on our table, what's our domain? 1, 2, 3, 4, and even 5. We added 5 up there. So the domain is 1, 2, 3, 4, 5. And again, I'm writing the domain. You can abbreviate just a D, your little bracket. 1, 2, 3, 4, 5. And then range was, if I go back up, 3, 6, 9, 12, 15. 3, 6, 9, 12,
15.
How come you think I didn't just go 3 through 15?
Because it'll be 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15.
Someone want to raise their hand and tell me? Why didn't I just go numbers 3 through 15 as the range? Kayla?
Because it's not all of the numbers 3 through 15, it's only 3, 6, 9, 12, and 15.
Go ahead. Yeah,
Is
and
that
it
supposed
doesn't
to-
include, like, for example, $5, because 5 wasn't one of our outputs. 6 was one of our outputs when our input was 2. So,
Isn't that supposed to like disappear?
no, this is not a magic pen. This is a real pen.
Yeah.
All right, I think then we're going to stop there. You can stop filming me.
Okay.